we're going to be talking about Nautilus, and in this presentation, I'll talk about like what is Nautilus, what is Kubernetes, what is a pod, what is deployments, talking about how to store data in Nautilus, then getting started, like reading the setup scripts and the YAML files, and also like specifying GPUs and knowing what's available. And then lastly, I'll talk a little bit about like the VS Code extension and like the terminal shortcuts and all that. And if there's extra time, I'll try doing like a demo as well. You guys can see my screen, right? Can someone confirm? Okay, great, thank you. So yeah, what is Nautilus? So it's pretty much just a big cluster of different servers. So professors can add to the cluster by purchasing their own machines, like Leilani has a machine, and they kind of donate it to the cluster. So that way we can all kind of share the resources. And what it runs on is Kubernetes. So Kubernetes manages all these different servers and kind of shows it as just one server or like one interface to kind of run your programs across many computers. And Kubernetes under the hood uses Docker. So Docker is kind of to modularize your program so that it doesn't, so that it's easier to deal with and it scales very easily. So yeah, so Kubernetes and Docker are used to scale the cluster so that there's more nodes, more servers, and more programs that can run on it. So next we'll talk a little bit about like what is a pod, and what's a deployment and what's a job. So pods, I know these photos are just AI generated, so just ignore them. I didn't have time to replace it with good ones. So yeah, what is a pod? So pod is essentially like your Docker container. So what I mean by that is it's your specific like computer, what you're actually going to run. It's like the basic unit of deployment. So when you run anything else like jobs and deployments, they and ultimately create a pod, and that's where your program is actually going to run. So why do you need deployments? Well, deployments kind of replace a pod when it dies. And they also last much longer. So pods die around like 6 hours. Like that's all they are like alive for. And then after 6 hours, Nautilus like deletes a pod. But for deployments, the pods can stay on for up to 2 weeks. And then after that, you get angry emails. So ideally, deployments you should create when you're like, deployments you should create when you're like working on something. And like, let's say you want to use that same pod for like 2 days or so. You keep that open, and once you're done working on it, you close it. And then the third type is a job. So jobs typically get like high priority, I'm pretty sure. Like it's used for when you're actively like training a model or you need like a lot of resources, and it's like high priority tasks, right? So jobs are usually for like training models and like doing a lot of like things that are going to take a long time and you don't want it to just die. So yeah, like the three different things are pods, deployments, and jobs. And pods are like jobs and deployments ultimately create pods. Like that is the actual computer. Um, but deployments last longer than pods. Like just creating, you can create a pod by itself as well. But it's recommended to create either a deployment or a job so that the pods last longer. All right, and then next up, we'll talk about storage. So storage on Nautilus is done through a persistent volume claim. It's part of Kubernetes. It's essentially you're requesting for that much, like a set amount of data. And that's what it is. For a PVC, you specify like the name you want to call your like drive, pretty much, how much data you want, and also if you want multiple pods to access it or just one pod to access it at any given time. Yeah, so this slide is pretty important. For PVCs, it's designed to store large amounts of sequential data, not tiny random reads and writes. So what that means is like it's really not recommended to store the like Conda environments and Python environments. Also, sometimes like applications on PVCs, it just slows the process down a lot. So if you're ever noticing like you're running a task and it just takes a long time, try storing it locally instead of on the pod. Or yeah, no, sorry, storing it locally on the pod instead of the PVC. You'll probably notice some like performance improvements. All right, and now getting started. So we're actually gonna talk about like how to create pods, deployments, and jobs, and also how to read the YAML files. Actually, probably should have gone. Oh, okay. Well, never mind. So how you get started with Nautilus is you install kubectl and kublogin, and preferably through Homebrew, and don't use Snap. I guess I should have put it here. I've had a lot of issues. Like, so this is like Linux, relevant for people that use Linux. Like, don't use Snap because it kind of like containerizes things. I think like isolates different things. Like for example, there were issues with kubectl talking to VS Code, so the extension just didn't work, and just also some other issues with like kube login, like the OICD login being installed separately through crew. So yeah, there's a lot of issues that can happen with using Snap. So always use Homebrew. It's much more like I've had the best success with that. Like no issues whatsoever. So yeah, step one, you go to nrp.ai and you log in. So even before you request to be added to the namespace, you need to like create an account, or else it just won't show up. And the next step, you download a config file from the NRP like getting started documentation, and you paste it, like you store that config file in this folder. It's in your root .kube folder. You'll have to make the folder yourself. It probably won't exist. Yeah, and so this like step 4 is kind of important. Like you might notice that your pods just don't show up, or you might get like a warning. It's because your namespace isn't set up. So I probably should have gone over this, but namespace is like your it's kind of like an authentication thing, um like what account are you part of in Nautilus? Like that's how to see namespaces. So you guys would be added to the IAEA auditor's namespace. And then once you graduate, you'll be added to the Gilpin Lab namespace. So it's just to keep track of people, and also like any PVCs you make and any pods you make and everything, like it'll be tied to that namespace. So you can't access a PVC in a different namespace. So just think of it as like an account. But when you first install Kubectl, it doesn't set up your namespace correctly, so you have to specify it manually. And this command here sets your default to, or wait, I think this sets the current. There's a different command to set, I think that, I don't know. Try this command. There's more information in the docs wiki for our documentation on Notion. But yeah, so if something's not working, try setting your namespace. And so the way you create pods and deployments and all that is through YAML files. So these are kind of like the config for what exactly you want to create. And this here is a sample config for just a pod. So if this is like you're just creating a pod, it's gonna die after 6 hours. These are all like the different parameters you need to set. So image here is specifying like which Docker image you want to use. You can use any image from Docker Hub. So it's a website, you go there, you'll see a bunch of different like Docker images. So it specifies like what like environment, like what computer you have pretty much. And it's just like, yeah, so it pulls from Docker Hub. But there are certain images that just like are cached on the nodes. Like I think PyTorch is just so commonly used that it ends up like pulling much faster. It can just use a existing copy of it. And then of course you'd have to specify like how much RAM you want, how many CPUs. In a different slide I'll show like GPUs as well. But yeah, and then request is like the minimum you want, and limit is like the maximum you'll use. So when you're actually creating this pod, Nautilus will look at like all like available resources, like all the nodes. So nodes are the actual servers, by the way. So it'll check like if a server exists with your resource constraints, and if it doesn't exist, it'll just like kind of loop and say like container creating, but it couldn't find a node that satisfies what you say here. Like if you put I want a terabyte of RAM, it's probably not going to find a computer with a terabyte of RAM. So make sure that like your specifications actually exists in the cluster. I'll show you a different slide shows like where to check what's available. So here's a deployment. So deployment config files are a little longer because you have to specify like replicas. So like how many like instances of that pod do you want at the same time? And yeah, there's also like a lot more labels. What I do is when I'm creating a new deployment, I just do like Control F and I replace the name to what I want it to be, and I just put the same name for all the different labels. I also use the same name for the PVC just to keep things consistent. We'll get into like how to create a PVC because the YAML looks like significantly different. And speaking of GPUs, so here the nvidia.com / GPU is how you specify like the count, the number of GPUs you want. And at the very bottom, you can specify like which GPU you actually want. But there's a caveat to that. So some GPUs you have to specify here, like in resources. So where it says like / GPU, you'd have to change it to like, for example, A100 would be / A100. And you would remove the affinity at the bottom. Yeah, so the NRP documentation has it all like listed, like which GPUs you have to manually edit this line versus which GPUs you change at the bottom. And here's an example job, very similar to deployments, except, well, it says job, and also like there's no, what do you call it? Like replicas. Instead, there's a restart policy and back off. So restart policy, set it to never. It's more like if your job fails, like do you restart the job? For our use cases, it's probably best to keep that at never. But then back off limit is like if your pod fails, how many times does the job create a new pod? So a use case for that is like, let's say you're training a model, and at some point, for some reason, your pod dies, like it just fails to train. You can set it to just retry the training again, but be careful. Don't just like if there's something obviously wrong with your code, it'll just keep restarting the pod, and that's just like a waste of resources. So keep that at like 2. So it'll do like, if you put back off limit at 2, it retries twice. So that's what it means. And this part in red is very important. So don't do sleep infinity on a job. Like we've actually had people that got banned from Nautilus for putting sleep infinity in a job. What that means is here in commands, you can put the command sleep infinity to make it just do nothing and just stay alive. So if you go to like previous, like for deployments, the command would be put sleep infinity. What that does is it just keeps the pod alive forever, or as long as possible. But for jobs, because they're kind of given more high priority and they can request more like memory and CPU and all that. So if you do sleep infinity, that's pretty much like an instant ban. So don't do sleep infinity on jobs. It's okay for deployments and pods. And now here's the YAML for a PVC. So key thing, name. You specify what name you want to give your PVC, and looking back at like other YAML, it correlates with this claim name. Also note that claim name and name here is different. Also the mount path and name is different. So the way it all links together is mount path is where it actually mounts on your pod. The name here looks for name and volume, and claim name looks for your PVC name. So usually when I'm starting to work on something, I would first create a new PVC, and I'll use that name, and I'll like just copy like Control F and replace everything here, like replace the Joey Moore abductive with that new PVC name. It's just very done that way. So yeah, back to PVCs. So another thing to know is storage class and access mode. So there's read write once and read write many. So read write once is where only one pod can connect to your like persistent volume, like your drive at one time, right? And read write many is multiple pods, like multiple deployments, whatever, can read and write from your one PVC volume. The benefit of read write once is that it's much faster. So if you want like high performance, then use Ruxef block. But if you don't care too much about performance, but you need like multiple pods accessing it to make it parallelized, use Ruxef instead. All right, so we've gone through storage, gone through pods, deployment jobs, also talk about reading the YAML file. And right, so for the YAML file, I mentioned if there's no like resource available, like if there's no node or computer with your specifications available, then it just like says error, or it just keeps saying like container creating, and says no nodes available. So to check that, you go to nrp.ai and then under user, go to resources, and you'll like see this panel. So here on the very left where it says name, that's the name of the node. And taints are like special nodes pretty much. Like if a node has a taint, you probably don't have access to it. So yeah, like an example is for Gilpin Lab, there's a taint that we have access to for a specific computer that Leilani bought, but other namespaces don't have access to that. So that's kind of like a thing. So usually when I'm looking for a free GPU available, I would make sure that the taints says like here is blank. So these are all the options you have for the filters. I put in blank for the taints. And there's GPU type, which is important because that's what actually goes on your YAML file, except for the exceptions. So like if we go back here at the very bottom, it says like NVIDIA A10, and that is exactly the same as GPU type here. And yeah, so what I would usually do is I put in taints as blank. I would put in the number of CPUs I want, or memory. Honestly, I might even put them last because that's kind of flexible. But I would put GPU free as like greater than or equal to 1. And I would go here to GPU memory and specify how much VRAM I actually need. Because those are kind of like, the GPU is like the most resource constraint thing on Nautilus because everyone needs to train their models. Yeah, so that's what I would do. And then later I'd fill in like the minimum number of CPUs I need and minimum memory. And then I would like, also you can't copy paste from this column for some reason. Like it just doesn't work. So you have to manually type everything out. Kind of annoying. But yeah, I type the GPU type into my deployment YAML. All right, so that's how you figure out what's available, and that's how you make a request so that it like you actually get allocated the resource. So now let's talk about like how do you run the commands, like how do you use the VS Code extension, and some like tips and tricks. So here are all like the important terminal commands. There's more, but these are all you really need to memorize. So step one is kobectl create -f. So that command lets you create anything like pods, jobs, deployment, PVC, because as we saw before, like these are all like the YAML files, and they would all be in like, let's say pod.yaml or deployment.yaml, etc. So here you would just do like kobectl create -f pod.yaml, and it creates the pod. Or well, it starts the process for creating the pod. And when you do kobectl get pods, you'll see that it says like container creating or something like that. And when you do kobectl describe pod, you see what's like actually going on. So it says like the status of your pod. Like, is it creating? Did it connect to the PVC? Is it pulling the Docker image? Things like that. Let's see. Oh, yeah. So once your pod is created, if you want to run commands inside the pod, you do kobectl exec it pod name -- bin bash. I hate this command because it's just so hard to memorize. So I made like an alias or like a shortcut command on my like .bash env or bash rc file, pretty much. And yeah, because I just can't memorize it, but that's the command so that you pretty much SSH into the pod, so you can run your experiments and whatnot. And then once you're done with your pod or deployment, you do kobectl delete deployment. That's what you should do. And then you put the deployment name as well. And then similarly, if it's a pod, you put the pod name and replace pod deployment with pod. Yeah. And there's a really nice like terminal program that lets you see like the status of pods and jobs. It's called Canines. Just kind of funny because like Kubernetes, people call it as K8s. It's just Canines. And then I found that there's Headsight. I mean, I haven't used it, but it's kind of what Kubernetes recommends as a GUI. It's probably good. It just gives you like a nice user interface for looking at your Kubernetes pods and deployments and whatnot. So for the VS Code Kubernetes extension, I used to use this a lot. It's very nice. Like it lets you attach a VS Code session inside your pod, which I think is awesome. And it's just kind of nice. Like it has good buttons to do like kobectl describe and kobectl like log as well. Like it's pretty good. But I say I used to because I switched to Emacs recently, so I have a different workflow now. But yes, if you're using VS Code, definitely use the extension and do all your work there. So the benefit is when you do attach VS Code, Visual Studio Code, it like it pretty much runs this command, the kobectl like exec it pod name -- bin bash. So you don't have to deal with it. You just attach Visual Studio Code and you're done. And then setup.sh. So I tried fitting like my setup script on here, but if I increase the font by 1, it just overflows. But why does this exist? So as I mentioned before, pods, or yeah, like the PVC doesn't, or is not designed to store a lot of small files. Um, so what I do is I set up mini conda each time I create a new pod or new deployment. So that's the main reason this exists. I also uh, like want to set up, for example, Git on there. So I store my SSH keys on the PVC, and I copy it into root each time I load the deployment, or deployment or pod. And I just have a bunch of other nice things like setting up my Git, installing Homebrew, setting miniconda, pip install, all that. So it's always a good habit to have one setup script that just does everything. Like for example, Z3, which is a Ethereum prover, installing that takes like all these commands and it just takes forever. So you don't really want to be like waiting around and typing each command separately, right? So yeah, that is my presentation. It's kind of nice because can you guys see my screen?
Yep.
Okay, perfect. I just ended up doing like a UTM for my class, so I can show you how I set up Nautilus from scratch. All right, so why is it so? How do I make it bigger? It's so zoomed out. Does anyone know how to increase font in Linux terminal?
Zoom in.
Oh, actually, wait. I'll just set the scaling. I think that would just fix everything.
Wait, we're getting kicked out of the room, so
Oh,
Okay.
we'll just join maybe.
on Zoom.
Yeah.
Yeah, I'll keep going because it's recorded and you guys
Okay.
can watch the.
Thank you.
Leave on this though, right?
Yeah, no problem. All right. So yeah, okay, so step one, I don't think I have kubectl installed. Yep. And it says snap install. Don't do that. Don't do snap install. Do brew. So I have homebrew installed. But yeah, so installing homebrew is just one command. But yeah, so do it through homebrew. Don't do it through snap. Like avoid snap. Right. So let's check. What is brew? I think it's just brew install kubectl, but no, it's not. It's Kubernetes CLI. All right, we got a brew install. And while that's installing, let's get the next one. So it's brew install kube login, I think. Yeah, it's just kube login. So I do that, paste. Yeah, so now I have kube login and Kubernetes CLI. All right, so now, actually, I think I should probably do it on. Well, now I need the config file. I'm just trying to think what's the best way to bring it to my virtual machine. Probably I have to log in here. So I go to nrp.ai. Then I go to login. Actually, I don't think you even have to log in. So you go here, you go get access, I think. They changed this a while back, but yeah. So download kube login, get config. Because like the config is kind of the same for everyone. Right. And now, is that files. Right, so now we need to move it to the .kube folder. So this is my home, and I need to create a new folder called .kube. Create. There it is. And I need to copy the config and paste it at .kube. Great. Now go here. Right, and then there's the set. Shoot, where do I? I'll post or I guess I'll give the slides to Leilani and she can like distribute it. But I'm looking for I guess I'll go to the terminal shortcuts. Yeah, so I was looking for setting the default namespace. So let me just copy that. And so for you guys, you would do AIEA auditors, but I'm on the Gilpin Lab namespace, so I'll do Gilpin Lab. Cool. Right, and now when I do Kubectl get pods, it should bring up authentication. Did it? Yes. So now you go, you see this website, and you search up Santa Cruz, log in. Let me find my password. It's kind of long. All right, copy. Hopefully universal clipboard works. Okay, great. Joey Moore. Duo. I think that's it. Oh wait, it also shows this. I'm gonna accept. It keeps showing it like every time. Just doesn't save that preference. It says success. And there we go. So now I've successfully set up Nautilus. And now let's say I want to go into a pod. So, well, I guess let's first create a pod. All right, so I'm gonna go back to my Mac OS just because I have things set up here. So let's go to. So here, this is the Nautilus repo, which is in the Nautilus documentation. So it has a bunch of sample YAML files that you can like play around with and create pods. So I guess we'll just do like the sample pod, and let's call it test Jonathan pod. And I'm pretty sure this is like the only thing that actually shows up. Like when you're like doing Kubectl get pods, but I don't know, I kind of like putting everything consistent, so you know exactly which pod it's referring to. If you want to do like, I think network ingress to get it in like, and anyways, that is more complex stuff, don't worry about it. So now let's go to a terminal, and it's the test pod. So the way you create it is Kubectl create -f test pod.yaml. It says created. So now what I like to do is I open up canines, and it has like an auto refresh thing. So I go down to my thing and I type D for Quebec will describe, and then R for refresh. So it just like auto refreshes. So yeah, right now it says pulling, so it's getting the PyTorch image, which has like PyTorch pre-installed and like CUDA and all that set up from Docker Hub. And actually, let's go to Docker Hub. So this is what I was talking about. There's a bunch of different images, but it's all like, what do you want pre-installed on your environment? And this is what we're using. That works. You can use any, and you probably have to modify your setup.sh to reflect that. Actually, speaking of setup.sh, I guess I can show it to you better, like more cleanly. So this is what I do. I like to, this is how you like create a shortcut for things. So I just made my own command because I kept I kept forgetting like which order to do all the things for creating a like Jupyter notebook thing, or adding your Python environment to Jupyter notebook. And yeah, I just have a bunch of other stuff like setting up Homebrew, Llama, Miniconda. And there we go. It says started. That's when you know everything's successful. So now I just exit out of that. kubectl get pods to see what pods are there. And there we go. We see the test pod. So now the command for going into it is kubectl exec, was it dash it, I think. Just go back to the slides. Yeah, dash IP pod name, dash bin bash. Does it not? It definitely has bash. Maybe there's no space here. No, there is a space. Oh, that worked. Why did that work? I think I probably messed up on the command. Let me look at what I have in what I zshenv. Oh, do you just put bash? I think you just put bash. Let me update that. So, because I swear there was like, you have to put bin, but I guess not. So let's try that again. So pod name dash bash. There we go. Just works. I don't know. It might depend on like the Docker image and whatnot. But yeah, so there we go. We have our pod. So this is running on Nautilus. Right. And let me show you a deployment that I have running. So it's the same YAML that you guys saw. test step. So here, this is the YAML file that I'm currently running, and it mounts to PVC volume, like my persistent volume claim. And you see it by doing, or yeah, let's look at my pods. So it's the Jonathan Morris Abductive Learning pod. Oh yeah, so when you're creating a deployment, it adds like a bunch of other like characters to your deployment name, making it specific for each pod. So that's the unique pod name. So sometimes pods die for deployments, so the rest of the strings like end up changing, but the first half of your pod name stays the same. Because if I do kubectl get deployments, oh, ctl, you'll see that that's it relates to the Joey Moore abductive deployment. All right, so now to go into that pod, kubectl exec -it pod name --bash. There we go. We're in here. And here you see PVC volume. That would normally not be there. And it only shows up because we specified PVC volume in our YAML file. So if I go in there, I have all my things in there, my setup script, my like my GitHub repo, and if I do ls-a, you'll see that I also have my SSH keys on there for convenience. So yeah, there we go. This was my tutorial, and hopefully that helped.